So first of all, some introductions of who you have with you today for this session. Starting off, we have myself, Dan Jones, who's the head judge for Formula Student in the UK, along with Elliot Brinkworth, who's deputy chairman, and Chris Slevin will be joining us for the Q&A session later on. From IPG Automotive UK, we have Elliot Heames, the managing director, Will Snyder, who's the sales engineer, and we have one of their colleagues who's joining us for the Q&A session also. Just to give you an overview, agenda for the next 90 minutes and a couple of sessions following that are should be of interest. So for this 90-minute session, it's split into approximately 30 minutes, and bear with me 1 second, I'm going to restart PowerPoint. It is auto forwarding, which is annoying. There we go, that's more like it. I've got control rather than it progressing automatically. So the next 90 minutes are split up into approximately 3 30-minute sessions. So starting off first with presentation from myself on the some details of the lap time simulation and driving the loop event. It's doing it again. How do I stop it auto forwarding? Right, third time lucky. So I'm starting with a presentation on the specifics of the event, then hand over to Will from IPG for a presentation on the specifics of the software for the lap time simulation and driver in the loop event itself, and then we have a 30-minute Q&A session at the end. Please feel free to add your comments and questions into the chat as we're going through the presentation. We won't pick any of those up during the first 2 presentations, but then we'll have those ready and available to start running through as soon as we move into the Q&A session. Some other sessions to make you aware of. So straight after this session, IPG are doing a further introduction to CarMaker presentation, and that's going to cover some of the, as well as areas related to lap time simulation and driving the loop. It'll also cover its capability for ADAS, so interest for FSAI, and also how to integrate the software with Simulink. And then from 2:15 till 4 o'clock, Elliot and myself have pre-booked one-to-one Q&As with a number of teams. So you guys know who you are for those as those come up. So we'll start off with so what is the LTS and DIL event? And it's summed up, it's a simulation of the Class 1 dynamic events using multi-body dynamic software, and that's split into 3 main elements. The first is the suspension geometry and gear ratio optimization exercise. That's completed over 3 of the dynamic events used in Class 1, so it's the acceleration, skid pad, and sprint events. There's then a design trade-off study where you're doing further simulation with some options on the car model and assessing the impact on the vehicle performance of those changes. And then a driver in the loop sprint event where you're taking your chosen upgrade package from the design trade-off study and the setup that you've derived from the lap time simulation to complete live driver in the loop laps, trying to achieve the lowest lap time on the sprint course.
Sorry, Dan. We're meant to be seeing your presentation at the moment because we can't see it.
Can you not? Can you see it now?
See it now.
Okay, right, fourth time lucky. So the slide on the screen at the moment is just an overview of it was what I've just been talking about. Because its PowerPoint seems to be auto progressing, I'll just I'll stay in the non-presenter view, so I've got control of the slides as they come up. So that was a brief overview of the event. Next question is, so why are we introducing this event? We want to do it to expand and improve the educational experience for teams entering the concept class. Specifically, there'll be representations of the dynamic events, including a live competitive element with the driver in the loop. That last element is dependent upon the event scenario that we're actually able to deliver in the summer next year, which is at the mercy of the pandemic with the coronavirus. We're all hoping to be able to have a live event and welcome the teams on site. Well, if that's the case, then we'll have a competitive driver in the loop event run on a single machine, and it will be very similar to the sprint event in format, but it'll be a couple of drivers from each of the concept class teams competing to set the lowest lap time on the sprint course. We also wanted to introduce it to lower the barrier to entry and enable all students to have the opportunity to use vehicle simulation software during their time at university and their experience informing the students. So we're well aware that some of the bigger teams have developed their own software packages or are using CarMaker or other software packages already, but there's lots of teams who aren't using vehicle simulation as part of their design and development of their former student car, and it's becoming ever more prevalent in industry, in automotive, in motorsport, all areas that you may go into. So it's really valuable that you get the opportunity to gain experience of using software such as this. Another benefit is that it provides supporting engineering rationale for your key design decisions. So as part of the concept, in the concept class, you've got to submit your design report, your business presentation, and depending how far progressed along you are with your design, sometimes you haven't got a great deal to present as you would do for a class 1 design report. By adding in the lap time simulation and driving the loop element, we've got the specific scored aspects where we're using a fixed car, so it's a level playing field for all the teams. But by forcing you to use the software, we're hoping that many of the teams will see the power in it and then use that as part of their, as you develop the design of your car, and then you'll be able to have evidence and design decisions you've made in your design report and design judging at the competition. And that really leads into the final point. So it'll provide a framework for onward development of a more complex car model that you can use in class 1. So we always hope that teams use concept class as part of a 2-year development program, where first year you're using to generate and build your ideas, and then the following year bring that car to competition as a class 1 entry. So the technical support and the software that's available, that's been provided by IPG, isn't just for the concept class entrants. It's available to all former student teams, and we hope you'll be able to learn how to use the software as part of the concept class, and then build upon that as you go through in your entry into class 1. So now looking at the specifics of the event, starting off with the suspension geometry and gear ratio optimization element. The objective of this is to achieve the highest overall score in the acceleration, skid pad and sprint events using a generic Formula Student car template. The reason we're using a generic Formula Student car template is we have no way of checking the validity of your car model in relation to both what you intend to bring to the event and what's realistically achievable in the real world. So you could engineer, or you could set up the model with very, very high downforce for no drag, or unrealistic masses and inertias for the size of the car. And it's just not possible for us to sanity check all of the team's entries. So we've chosen to set the event up very similarly to how we did last year for the virtual Formula student, where the major masses, inertias, centre of gravity, and the power and torque curves of the vehicle are fixed. It will be a fixed tyre model, so you're all working with the same available grip from the four wheels. And CarMaker can be configured with many different suspension configurations, but 90–95% of Formula student cars feature double wishbone suspension front and rear. So we're fixing the suspension configuration as that type. But then all other suspension parameters will be open. So the vehicle will have a fixed wheelbase and track, but then you'll be able to change the suspension inboard pickup points within some predetermined ranges. And then so the rest of the kinematics and the kinetics, so your spring rates, your damping rates, anti-roll bars, are all the tunable elements. We'll also provide some optional gear ratio sets. So you'll have a different number of discrete gears in those gear ratio sets, and also different gear ratios, but there'll be a fixed time to change gear for each. And then within all of those tunable or variable parameters, some of them must be the same for all events, and others can be varied between events, and that will be published in the rules of what must be fixed and what's tunable. The idea with this is to make it very similar to running a car at the actual event. So once you scrutineer a car, you've got all your stickers on the nose cone. There are only certain aspects that you're allowed to change. So beyond that point, you wouldn't be able to change the gear ratio set. That will be set for the whole competition. And for example, your aero package, you wouldn't be able to change the front or the rear wings, but you are allowed to adjust the angle of attack of the wings within their range of adjustability. So the way we set the event up is to be similar to what you'll then experience as a Class 1 team. Following that, we'll then ask you to move on to do a design trade-off study, and that's to understand both the positive and negative impacts of adding an aerodynamic package and alternative powertrain options to your vehicle concept. And then using the same software and car model, your task is to simulate the effects of the provided upgrade packages on the vehicle performance, and then summarize your findings in a short report using data from your simulations to support your explanations. So I always joke, it's the first law of thermodynamics, and the first law of engineering is that everything is a compromise. So with every positive effect, there's a negative of what you're bringing, and your task as engineers is to maximize the positives and minimize the negatives for an optimal package for your particular vehicle. The report format will be very similar to the design report that you have to submit, but it will be shorter in length. I'm expecting it will be 4 pages maximum, 3 pages text, and 1 page for illustrations, something like that. Then for the final scored element of the competition, it's the driver in the loop. And in this, you'll be using the vehicle configuration setup from the previous 2 events. So your optimized suspension geometry and gear ratios, along with your chosen upgrade package. And then you'll be running those in a competitive real-time run of the Formula Student sprint course. And the important things to take away from that exercise is, one of them is to understand the importance of consistent and predictable vehicle behavior versus peak performance. On the earlier lap time simulation stage, there'll be a driver model that's driving the car, and that will drive the car exactly the same way every single time you run an iteration on a particular event. But obviously human drivers are not as repeatable, and it will range on your driver's capability, whether they're sort of semi-professional and have previous experience of racing, or whether they have little experience behind the wheel. But quite often, extracting having the fastest setup, it makes the car more difficult to drive, and so there's a trade-off to be had between peak performance and being able to repeatedly deliver a low lap time on the sprint course. As I touched on already, we're targeting this to be a live competition, but that's pending which event scenario actually takes place next summer. If we're not able to have a live competition and live driver in the loop, then we'll switch to a pre-recorded video submission, similar to that we did for the virtual dynamic events this year. So at the moment, the full event format and software tools are still under development, but our expected timeline for both events is that by the end of this year, we'll publish the event-specific key dates, and that will be firm dates around the rest of the framework below. So in January 2021, shortly after teams are confirmed, after registration, we've selected the teams. We'll publish the final rules and make the software available to the teams. Then around late May, early June next year will be the submission dates for the lap time simulation and the design trade-offs study. So the design trade-off study will be a normal submission via the Formula Student question database. On the lap time simulation side, you'll be submitting a package of files, effectively the input deck to the simulation, and then that will enable us to rerun your simulations, ensure that you've complied with the rules in terms of what you've adjusted on the vehicle, and then every team submission is run on run against each other, and we score the events based on the lowest time achieved in each of the events. And then finally, at Formula Student 2021 will be the competitive driver in the loop element. So slightly quicker than the half hour intended. Apologies all for the technical issues. I'll now hand over to Will Snyder from IPG, who'll give you a presentation, more detail on the software.
Thanks, Dan. Just take a minute to get this sharing properly. Hopefully you can all see that now. Okay.
Can see that fine, Will.
Brilliant. Okay, so as Dan said, my name is Will. I work for IPG Automotive in the UK, and we're going to go over CarMaker in the next 20 minutes, half an hour. So the idea of this is to give you an idea of why we should be using simulation, what CarMaker is, how you can use it, and then how you can apply for the software. So these metrics are from an OEM, but in my experience from being in Formula Student in 2012, I think they also apply to Formula Student. Real prototypes are only available for a very short period of the development cycle, and it's often right at the end of the development cycle. Even if they're available, most engineers won't have access to run their tests, and the testing is entirely dependent on weather conditions, or at the moment, corona lockdown conditions. This can lead to all sorts of problems, and these problems are often just found right at the end of the development cycle, and that's when they're most difficult. So that's where virtual prototypes come in and virtual test driving. With virtual test driving, every single engineer gets access to a prototype for the entire design cycle. It may be a virtual prototype, but there's still a wealth of information that can be provided, and the information collected can be used to make the real world testing far, far more efficient. So we'll come on to some of the applications later, but by the end of this presentation, I hope you'll see the value in virtual prototyping, and you'll see how it can be used for the lap time simulation event. So just a quick overview of CarMaker. CarMaker is a complete solution for virtual test driving. It allows you to build a vehicle, it allows you to build an environment, build a scenario, and test your vehicle capabilities any way you want. So it has an inbuilt driver model that can execute whatever maneuvers you want to do, and the results of those maneuvers are reported instantly, much like a fully instrumented test vehicle might report your results. Once you've defined your test and you want to expand it with some variables, you could go into the scenario editor or the vehicle and define certain parameters as a variable, such as maybe you want to run a certain test at different speeds, or you want to run a certain test with different spring rates. If you set a variety of spring rates, you can start an array of tests that will be completed automatically by Test Manager, and that makes your design studies really easy. So you could use this right at the beginning of your design cycle to just try out loads of different configurations and see which one gives you the best performance throughout every single different event. The last point to make on this slide is CarMaker integrates with a wide variety of commonly used industry tools. So maybe might have been the MathWorks talk earlier. We can co-simulate with Simulink, so that you can bring in your own models into the car. We'll go into that a bit more later, and again later in the session this afternoon. So just to start with now, we'll go over the 4 pillars, if you like, of CarMaker. So the first stage is to build your vehicle model and parameterize that to be as representative as possible. You then need to look into building your road model. In Formula Student cases, it'll probably be a set of tracks. In OEMs, it might be a network of roads throughout town or a car park. And then you can use Scenario Editor to build on your road model with traffic and environmental factors such as road furniture, pedestrians, other cars, traffic lights, or just beautification with trees and buildings, for example. The last stage then is the driver. Now the driver model is parameterizable in CarMaker, so you could maybe use the inbuilt driver as a nervous driver, or you could specify them as an aggressive driver. In this case, you're probably going to be using the racing driver, and we'll come on to that later. So looking at the vehicle model in more detail now, the vehicle model is modeled with a systems-based approach. So that's to say that you're modeling the characteristics of each system as opposed to every individual component. I'm sure you can imagine if you try and build every single component in a car and try and run it in real time, it won't function, and it will be far too complicated to actually build it. So in this scenario, you are just modeling the characteristics of each system, and I'll give you some examples in a minute. So each system can also be modeled with various levels of fidelity. So that could be anything from a generic value, or it could be a full Simulink model. So as an example of that, we could look at the vehicle damper. You could specify that damper as just a simple damping coefficient, or you could specify it as a lookup table of damping coefficients, or you could replace that damper entirely with your own Simulink model to model an active damper, for example. But the one thing we always push is purpose-driven fidelity. One of the downfalls of engineers is we like to do things properly. So often we're looking way too hard at trying to make the most complicated model we possibly can on every single system. But often that's not necessarily needed. So if we take a look at an ABS system, for example, if we just want to prove that ABS system is working when you lock up a wheel, we don't need an accurate powertrain model. It's almost irrelevant to the test. In fact, we don't even need a particularly accurate tire model, so long as we can lock up the wheel and see that the ABS system responds appropriately, we've proven that our test has worked. So although there are lots of levels of fidelity available, you really want to look at what the aim of your test is and then choose the appropriate level of fidelity for each system. So as an example, let's look at a couple of these systems. If I take the powertrain system as an example, when you open that in CarMaker, you can look at all of our inbuilt different powertrain styles. So you can just specify a combustion engine or a parallel hybrid, an axle split hybrid, a power split hybrid, serial hybrid, or you can go completely electric and have 4 motors, 2 motors, front wheel drive, all wheel drive, rear wheel drive. And then on top of that, you can then specify your gearbox. You can put it as automatic, manual, dual clutch, and you can even put it with or without gear losses. So within CarMaker, you can just select your powertrain that you want to use and then fill in all the different parameters that it's giving you to model that. So for a simple one might be with a combustion engine, you're going to put in your torque curve. And that will be enough for CarMaker to do something with it. If we move on to the vehicle body, for example, you could have it as simple as a rigid chassis with a single mass and center of gravity. Or we can make it more complicated and say, now we've got a flexible chassis with multiple trim loads to represent the driver or different fuel levels, for example. So again, we can choose the different levels of fidelity. The last one I'll touch on here is sensors and vehicle control. CarMaker has a load of built-in virtual sensors. So you can specify sensors throughout the car. This is particularly relevant for maybe the FSAI guys as well. And use our inbuilt vehicle control methods. So we can add a longitudinal controller or a lateral controller based on the sensor readings. Or you can integrate your own MATLAB model or C code that will read those sensors and apply the appropriate response to the car. So that gives a really, really quick overview of the car. The only other thing to mention, which is important to Formula Student, is your kinematics. So with the Formula CarMaker license, we've also included Ipg Kinematics. So Ipg Kinematics is a tool that helps you model your suspension geometry and easily create the kinematics and compliance data required for a high-fidelity CarMaker model. It comes with a load of suspension types built in, and that will include double wishbone, which, as Dan said, will cover most of your uses. So with the suspension, you can go for a low fidelity 2 degree of freedom or 3 degree model. You could even add rear wheel steering. What Ipg Kinematics is going to do is take your model and your suspension setup and produce all the data required to do full kinematics and compliance for your wheel travel, steering. And that data will feed directly back into CarMaker. The license will come with a user guide on how to use this as well. So the next stage then is setting up your road file. Your road file can be anything you want it to be. As you can see on the right there, we've got scenario editor. In there, you can use the tools on the left to build and beautify any roads you want. So you can build roads, junctions, you can add trees, traffic lights, traffic, buildings. You can build whatever you want to do. Or, as I know people have done in the past, you can just import your road from a file. So we have an example Formula Student track from another UK team that have GPS data from Formula Student 2018, and they've managed to import that into CarMaker and build a track according to FS UK 2018. Once you have your track, you can adjust things like your track friction. You can put lumps into the surface, for example. But to make life easy, when you apply for a Formula CarMaker license, we will send you a link to a repository that has some track models in it. We're a partner of Formula Student. We're also actively working to make those track models better and better as quick as we can. So the last section then is the Ipg Driver. Oh, there's a spelling mistake in that, that's annoying. So the Ipg Driver is a mathematical model of a human driver. So what we mean by that is it's going to calculate a route, but it's also going to try and act like a human. It's not going to react in a way that a human couldn't react. It's not going to react to things that a human couldn't feel. And it's only going to act on the pedals, the steering, and the gears. So the first stage of the Ipg Driver will be to look at the scenario in the vehicle and your driver characteristics and set a static desired course and velocity. That's essentially choosing a route around your track and what velocity you can do each part of that route in. The next stage when you start the simulation is the driver acting on the pedal, steering, wheel, and gears to follow the STC and the SDV as best it can within the vehicle's limits. For a standard driver, it will probably stop there, but for a racing driver, we go further and we go into driver adaptation. And with driver adaptation, you can run Ipg Driver through a standard test in the vehicle that you're trying to test, and it will find some limits of the vehicle. And that will get you much closer to the fastest lap time you can achieve. But we can also go one step further, where you can drive that driver and vehicle around your track, and lap by lap, it will learn how to make itself faster. If you're interested in that, you can join our expo session later, where Mariano will be giving an example of how to tune your Ipg Driver model. I touched on earlier the CarMaker integrations. So we'll just go into a little bit more detail here. I think primarily Simulink is going to be your main integration that you would use for Formula Student. It's a really powerful tool. You can either use it as a plugin or you can use it as a co-simulation, which means launching CarMaker from Simulink and having the models running together. With Simulink, you can pretty much overwrite or adjust any part of the vehicle or the simulation. So as I mentioned earlier, if you wanted to do an active damper system, you could remove the CarMaker damper and replace it with an entire Simulink model. If you wanted to make your powertrain even more complicated, you could take the entire powertrain out of the vehicle and replace it with one big Simulink model. So it's really makes your vehicle infinitely adjustable. We also integrate with some common powertrain packages. So if you use GT Suite or ABL Cruise, you can natively bring those into CarMaker and use those models to co-simulate with CarMaker. If you've got plugins, we also support C code and the FMI FMU format. And much like Simulink, you can use a plugin to overwrite parts of CarMaker or enhance your vehicle in any way you want. Again, later on in our demonstration in the expo room after this, we'll do a couple of Simulink model demonstrations just to show how you can co-simulate with Simulink. So I'll just touch on now a few areas of application, and these are the 4 key ones for Ipg CarMaker. We do a lot in autonomous vehicles and ADAS, but we originally started off as a vehicle dynamics company. So our software evolved from vehicle dynamics, we moved into powertrain, and now we do a lot with autonomous vehicles and ADAS. I'll touch mainly on vehicle dynamics, powertrain, and autonomous vehicles here because I don't think the ADAS is as applicable as those 3 for this competition. So the use cases showing here are primarily for OEMs, but definitely they apply to Formula Student as well. In particular, we look at the handling performance investigation and the lap time performance investigation for Formula Student. But the OEMs might also use it for steering feel evaluation or riding comfort or benchmarking competitive vehicles. And we even have people using it now for stability control homologation for their vehicles. So in terms of Formula Student, as I said, we'll be looking at the handling and looking at the lap time performance. So CarMaker can be used to run different setups and find the best setup to find the best requirements for skid pad, sprint, and acceleration. They all have different requirements of the vehicle dynamics. So you're looking to find the best compromise for all 3 events. You can do that by adjusting the car and running your lap time optimization, or you can do it through Test Manager by running 100 different setups on the same course and seeing which one does best. You might also take this further and go into what Dan was describing earlier and test the effects of aero on your car. So you can define an aero profile for your car and then evaluate whether that performance change or the increase of the reduction in lap time is worthwhile. If there is a reduction in lap time, perhaps you'll find the extra mass and drag of the wing reduces your car's performance. So that's really important because you can run these studies right at the beginning of your design time before you've ever got a virtual prototype. And remember, one of the best benefits of simulation is repeatability. If you send your driver out on the track and that driver gets better with each lap, or it starts to rain, or any number of different scenarios, you lose repeatability in your test, and your ABA testing doesn't necessarily work as well. With simulation, you're always going to be repeatable every single time. So the next core area is powertrain. And I think it's really powerful here because you can use CarMaker right at the beginning of your design cycle to define your concept. There are a lot of big decisions to be made. Should we be, if you're using an ICE, should we have a turbo or not? Should we use a 4-cylinder or should we use a 1-cylinder? All of these can be modeled in CarMaker and tested throughout the events and see which one's going to give you the best performance. So again, these ones you're seeing on the screen largely targeted at OEMs, but they also apply to Formula Student. With your BEV or hybrids powertrain concept studies, there are so many different ways you can do the architecture of those vehicles. To be able to test them all in the virtual world before you actually have to build your vehicle gives you huge benefits in time and cost. For the endurance event, for example, fuel consumption is really important. So you might be developing your different strategies for how you're going to use fuel or how big your fuel tank needs to be. You can run an entire endurance event in CarMaker, and with a good enough powertrain model, you'll be able to tell how much fuel you're going to need. And the same applies to the electric side of things. You can know what strategies you're going to need to use to get your battery to the end of endurance. And if that strategy is the best strategy to give you the best time and balance to battery power left. We even have some students now in other teams in the UK that will use a combination of your powertrain and vehicle dynamics to use torque vectoring strategies So you could, again, bring these in through Simulink and model torque vectoring strategies to combine both of them to get you the best lap time you possibly can. So lastly, just autonomous vehicles. We'll talk about that. And it's an ideal tool to develop and test your autonomous vehicles, because robust testing and the amount of hours and miles required to validate your autonomous vehicle model is just unfeasible for most people. Even in OEMs, they're now saying they have to do millions of miles of testing to validate these models, and you can't do it in reality. So that's where virtual prototyping in CarMaker really comes into its own. CarMaker has its own suite of sensor models built in, and they go of different fidelities from an ideal sensor model to a high fidelity sensor model that's, instead of just saying that's a car, it's saying that's got 70% probability of being a car, as an example. Or you can just get a raw signal out of your virtual sensor. And when you combine those with your vehicle controllers within CarMaker or your own vehicle controllers from Simulink, you can test any algorithms you want in the virtual world before you ever have to hit the track. And that means by the time you hit the track, your car is much, much more mature than it would have been otherwise, and your track testing is far more beneficial. You can also create a huge array of different tests in Scenario Editor. So you can test your algorithms in many, many different scenarios that you possibly can't replicate in the real world all the time. So it just ends up with a much more robust model that's easy to test. So my final point here is just also how integrated modern cars are and Formula Student cars have become. You often can't just model your powertrain anymore, and you can't just model your vehicle dynamics or your automated driving. All of these systems are entirely reliant on each other and have dependencies on each other. So by having a whole vehicle simulation package, you can find those dependencies and tune those dependencies at an early stage. Without modeling the whole vehicle, you'll end up having 3 teams developing 3 systems, and when you get to track, they almost inevitably won't work together, and all the time you set aside for track testing will be actually fault finding. So it's really, really helpful as a virtual world to be able to find those dependencies at an early stage and fix them as early as possible. So I hope that's given you an idea of CarMaker. As I said, we'll be going into some more detail in the expo session afterwards. So now I'd just like to finish by telling you what you can do to get Formula CarMaker. So to apply for it, just visit our website, go to ipgautomotive.com. There's a tab at the top for support. Go support licenses Formula CarMaker and complete the registration form. As standard, the registration form will give you 2 node lock licenses per team. And by node locked, I mean that means the software is locked down to 1 laptop or 1 computer. And that will include your Ipg Kinematics as well. If you need more than 2 licenses and you can give us a reason for it, just email us with a special request and we can grant you 2 further licenses per team. When I say per team as well, if you're a university with a team and an electric team and an AI team, all of those count as separate teams because they have their own, they can get their own licenses. And if you need further help, when you get your Formula CarMaker license, it will be delivered with a link to a repository, and in that repository you'll find a CarMaker project. In that project has some basic CarMaker vehicle models, it has some examples, and it has some tracks in there as well to get you started. And also in there, if you look in the documents folder, you'll find a Formula CarMaker user guide to get you started. If you go into the main GUI as well and go to the help section, you'll find there's a quick start guide and standard user guide and guides to all the really detailed stuff you can do with CarMaker. If you do get stuck though, we have our dedicated email address. Just email us at formulacarmaker@ipgautomotive.com and we'll be happy to help you out. So I hope this has given you an overview of everything you need to know for CarMaker. I know it's a very high level overview, but if you have any problems, feel free to find us in our expo booth. And after this, we'll be doing a session to go through some MATLAB examples and some lap time optimization examples. So with that, I'll pass back to Dan.
Great. Thanks very much, Will and Dan. I think that sort of now brings us to the Q&A session, part of this session. We've had a few questions come in. But I think in order that we can sort of fill the time effectively, just where people are thinking of sort of subsequent questions, We might do a bit of a panel discussion around some themes that come out from Dan's presentation and also Will's as well. Yeah, I think from my perspective, this is another really interesting development, and a positive that's come out of COVID is, you know, the 2020 competition demonstrating what can be done in this area, and opening up an opportunity to add a bit of a dimension to concept class, but also providing, you know, another very powerful tool to all Formula student teams that can sort of support their design decision making, their development of their cars, and hopefully make them successful. So I think we will start with the questions we've got. I think we've got 3 questions. They are probably all aimed towards Dan from a rules perspective. But I think maybe if we could also ask sort of IPG colleagues as well, beyond those questions specifically around Formula Student and rules, maybe to give some thoughts on how teams might be able to use the software in terms of their more detailed design, if that's what they want to use the tool for their concept class and FS class entries. So start with the first one, which is from Henry Jury. Is the LTS driving the loop event likely to be done in chassis sim, or will it be switching to IPG CarMaker? Hopefully fairly straightforward answer for you, Dan, but I'll pass over to you.
Thanks, Elliot. So we are switching to Ipg CarMaker for the lap time simulation and driver in the loop, both in concept class and where it is a mandatory event. But then, as we mentioned in the presentation, the software and the technical support are available to all teams, both in concept class, class 1, and in the Formula Student AI. Chassis sim, the chassis sim event that we ran last year was very successful. It effectively turned out to be a proof of concept. But then we explored options for who we could partner with to take the event forwards. And as was announced a couple of days ago, we've got an initial 2-year partnership with IPG. But on both sides, we're hoping that it's a very successful 2 years, and we continue that as a long-term relationship between IPG and Formula Student. And the lap time simulation and driver in the loop event is really just the start of the things that we can do, both as event organisers and what the software can offer to you as teams and competitors, to aid your educational experience as part of your competing at Formula Student, and improve your skill set as engineers before you head out into gainful employment after completing your degrees.
Thanks, Dan. I'll move on to the second question, which is from Simon Baker. If a team doesn't enter a car with aerodynamic devices, would an upgraded bodywork design count?
So there's a subtle difference with the lap time simulation and driving the loop versus the other elements of the concept class, in that the premise is you're all given the same car and the same upgrade packages to work with. So we don't want people playing a game of top trumps and just picking the best tyres or the best aero package. It's about, given a fixed vehicle and set of parameters to work with, it's optimizing those and achieving the best performance within those. That's the specific scoring for the lap time simulation and driving the loop event. But in concept class or class 1, you are welcome to take that template Formula Student car and develop that further and use that to justify the particular design decisions that you're making, either in concept class or class 1, to explore setup changes on your car before you go and take it to track. So you've got a good idea of the sensitivities that your car should exhibit, and then you can try and validate those and see if that holds true when you go testing. So I think the summary of that question is just the important distinction between what's the closed box framework for the lap time simulation and the driving the loop event, but then the completely blue sky limited by your own thinking and imagination capability that the software is providing you for use in the other elements of the former student competition.
Dan. And Elliot, Will, Mariano, do you have any sort of thoughts on what teams might be able to do in this area around bodywork and aero, and perhaps where there's a bit of overlap?
Certainly. So with aero, I mean, I think I mentioned it briefly in my presentation. It's so beneficial to be able to make that decision early on. So to be able to do a study in CarMaker, using, maybe you've designed a wing and got some CFD data from it to know what your downforces are. You can put those into CarMaker and run your lap time, see whether it's beneficial. That I know from experience, the effort that goes into making an aero package for a car is massive, and it changes the suspension setup you might want as well. So to be able to use simulation at an early stage and make that decision really can be beneficial and save you a lot of time, money, and effort. In terms of your chassis, I think you could also use CarMaker at an early stage to work out what your chassis stiffness needs to be. So when it comes to designing your chassis, you've got to look at the torsional stiffness from an early stage to work out, to make sure the architecture that you've gone with is stiff enough to give you the best handling. It's really about making those, we call it front loading all your work. So by bringing all these decisions right to the beginning in simulation, you don't have to make them later on when you've got a prototype that's already made. Once that prototype's made, it's really hard to edit it. It's the hardest time to make changes. So by front loading it, you're really going to save yourself a lot of time, money, and effort.
There's a couple of interesting points in there to take on and discuss a little further. So simulation is a very, very powerful tool, but it's only ever as good as the data that you're feeding into it in the first place. So you can start off some concept evaluations with some rough differences between a different aero package or looking on your chassis stiffness. But then as your design develops, so on your aerodynamics, you might want to look at pitch sensitivity of the aero or sensitivity of the proximity to the ground. And that will then feed into further setup optimization, or how you actually choose to take the detailed design of that particular element. And on chassis stiffness, one thing that teams will often forget. So I refer to it as installed stiffness, and it's the combination of the chassis and all your bracketry in between that the loads are being passed through. So it's not only thinking about the stiffness of the chassis, the big bracket in Colin Chapman speak, but it's also all of your attachments for the suspension and going through the load paths. And you can have estimates for the stiffness of those elements from FEA, and you'll be able to configure all essentially as an elastokinematic parameters in CarMaker. The capability there is primarily for road car development, where you have bushes with different stiffnesses and damping rates in different directions, but you're also able to leverage that and use that to put installed stiffnesses in for your suspension elements on a racing car. It's something that, as long as you design something to be stiff and strong enough, you could probably leave it set infinitely stiff in the software. But if you've got the time and the engineering application, you can start to put that in, and you could do a design study and just prove how stiff is stiff enough, rather than engineering a heavier bracket or chassis.
Thanks very much. And final question, and I'd kind of ask people who are watching the session, try and come up with a few more questions. Hopefully this is inspiring you to sort of ask a few more questions. Otherwise, I've got to fill. But move on to the last question, which is from Connor Waterman, who's asked, with a standard FS tyre model approach, will this be based on a single tyre manufacturer, and what compound stroke sizes will be made available, as there are many options in the market? I guess that's a question for you initially, Dan.
And it's the answer is similar to one of the previous questions. So for the lap time simulation and driver in the loop events, it's a fixed car parameters with a limited number of tuning options, and your job is to optimize around the given package. So we will choose tyre data from a commonly used Formula Student tyre to make it representative. We're trying to make sure that that is based on actual measured tyre data from the tyre consortium. But then, if you choose to use the software for the specifics of your vehicle, and you have access, you're a paying member of the tyre consortium, then you'll be free to configure the software with any different tyre characteristics that you choose to put into it. But at the same time, if you don't have access to detailed tyre data for your particular choice, then we'll hopefully be able to provide a base tyre that's a commonly used Formula Student tyre, and then if you're using a different tyre to that, its performance won't be hugely different from that. Obviously, it's better if you have the exact tyre model, but you will be starting from a Formula Student-based tyre, not a 20-inch high-performance road car tyre or some other racing slick, for example.
Thanks, Dan. And to sort of IPG
was the name that was escaping me. So it's the CalSpan Tyre Consortium. Lots of teams out there will be familiar with getting the data for Hoosiers, Goodyears, Avons. Yeah, they've tested many different Formula Student tyres over the years on that rig.
And to that, which is really helpful. So for the IPG team, presumably tyre data and modelling is of interest to quite a lot of your clients. Have you got any thoughts that you could share with the teams on sort of how to approach that? I guess particularly maybe starting off from the basics and working up to more sophisticated models.
Yeah, who wants to chip in first?
I'm going to let you do that.
Yeah, I think so. Will touched on it earlier on. Purpose-driven fidelity. What is the problem you're trying to solve? I talk to kind of OEMs and industry customers about this all the time, and I think no matter what it is you're involved within the Formula Student teams, whether you're the CFD person or the Ipg Dynamics person, I think the question I would start asking is, what is the problem I'm looking to solve, and start your simulation from there. And I think that's very important because, as Will talked about, you can get hung up on massive levels of fidelity that you don't really need, and you overcomplicate things. Keep it simple. I think, Dan, you said this earlier on. Keep it simple and build up from there, so that you've got the right level of accuracy, not the maximum level of accuracy. Somebody else asked a question earlier on about accuracy of data, and I think that's my general advice. And just try and build your capabilities together as well. So there was a question earlier on in our booth between a couple of teams within the same university, and they weren't quite sure who was doing what. Well, talk to each other. If I was going to talk to an industry customer and say, and there was like two teams using similar types of software, the first thing I would do is ask them to sit down together and share their knowledge, and they would advance their capability and their knowledge incredibly quickly in doing so. So that's another thing to do. Talk amongst yourselves as Formula Student teams around the event. Talk amongst yourselves as Formula Student teams within a single university as well, and share knowledge as fast as you can, and then build up the capabilities. But start simple and add in complexity when you're happy you're getting the results that you're after. I think that would be my approach.
Great, thank you.
Just to add, bring it back to tyres for a second. We're not going to leave you high and dry. When you apply for a Formula CarMaker license, we give you access to a repository full of data, and that will include some tyre data to start with. So you're not going to start with nothing.
Smashing. We've had another question in from Jeff Cunningham. Can the panel comment on the suitability of CarMaker for driver assessment and training? One of the issues each year is getting enough track time to select and then develop drivers. Associated with that, it would be helpful to have an accurate representation of the typical endurance track. So I guess the kind of latter part, maybe Dan or Chris could comment on.
Yeah, and I think I'd like to start on the question and hand over to the IPG guys on the first aspect. So I think one of the key differences between a professional racing driver and a keen amateur or a learner is consistency. and the ability to record what's happening whilst they're doing it, and then relay that accurately for developing setup later on. And whether it's sim racing or a driver in the loop software package with IPG, what that enables you to do is pound around the track many times with the driver without the risk of crashing and damaging your precious car, causing injury to anyone, or burning up expensive tires and fuel. But the like anything, when you practice, you need to be practicing the right way. So you can just go around and drive something around for fun, but if you're not working on improving your capability as you're doing that, then you're not maximizing the potential that it has there. In terms of how useful it is for that, very useful for training a driver to both drive repeatedly and drive consistently, learn to pick up braking markers, turn-in references, when to get on the power coming out of corners. Of how accurately it will recreate the driving experience when they get in the car for the first time, that really is dependent upon the accuracy of the simulation and the data that you fed in, and how well your car matches the your design data that you think you've achieved. There are many different sim racing packages out there, and so we used Assetto Corsa for the virtual dynamic events last year, and there's a representation of the Formula Student sprint track that's available to download on Race Department. There's an interesting nuance between sim racing and professional software packages such as IPG. I think the sim racing, the physics model is it's very good, but it's approximated, so it can run effectively for multiple cars. So you can have multiple cars on screen, and for a spread of computer capability. And they are, by the nature of the market, they're forced to spend a lot of their processing capability on very nice graphics and the presentation of the game. So the physics accuracy of the top sim racing titles is very good, but they're not running full physics models that the software like CarMaker is running. So it's a full multi-body dynamic representation of as many elements as you choose to put in between the tire and the body of the vehicle, with compliances, stiffnesses, damping effects, etc. So if you spend the time and the effort to get a very accurate representation of your vehicle, then the physics model that's running on the on this software should give you a more accurate representation of how the car then behaves on track. I think, happy for the IPG guys to carry on, talk a little bit more about some of those specific points in there. A sprint track will be provided as part of the lap time simulation and driving the loop element, and it'll be very easy for us to extend that to include an endurance track. So I'm sure we'll look to include that as part of the package.
Yeah, absolutely, Dan. I think you covered most of the points there. We will be providing a track, and you can take that track and make it as realistic as possible as you want. If you want to make cones or trees or barriers, anything that looks like a former student track to give the best feel, you can add that. And the physics model is great, as Dan said. In terms of the driver in the loop experience, simulators for driving the loop can go from anything from a PlayStation steering wheel to a fully dynamic, massive simulator. And the bigger they get, the better your feel will be as a real car. The package that I imagine most former student teams will be using will be a PlayStation style setup for your driver training. So while you get the experience of driving around the track, there is limitations to what that hardware is going to do in terms of feel, and it won't feel exactly like a car, but it'll be good to get an idea of the track.
Great, thank you. And just to sort of, I think that has answered the question from Duncan Codd about the endurance track. And Mike Chester's asked, can you import an XY table of points of a known track to generate a road in IPG?
Yes, I believe you can. You can definitely use GPS coordinates. Mariano, can you use a table of XYZ coordinates to create a track in Scenario Editor?
Yes, you should be able to do that. Yeah. The road file is an ASCII file, is a text file, so you can access it with a text editor and potentially input the XYZ coordinates. Yeah.
Excellent.
We'll be
Thank you.
sorry, Elliot, we'll be working on various, as Will mentioned a little while ago, various track elements and tire elements as we go through the program as well. So hopefully we'll see more and more data populated for people to use.
Excellent. So I think that's all the questions we've been asked. If there's any more, then please pitch them in. We've got, I guess, just shy of half an hour left to go.
I think there's one very technical question, but from Henry Drury. So, is it possible to import a PAC 2002.tir file into CarMaker? He's asking that question because it's taken them significant time to assemble their tire model for the year, and it'd be great if they could move it directly into CarMaker.
It should be compatible, so we are able to import MF Tire 6.2 as the latest version, so all the previous versions should be compatible. We can double check it for you.
I'd say give it a try. If you come across issues, then drop something to the technical support and we'll look into that for you. But yeah, as Mariano said, MF Tire is compatible, so should be doable.
Yeah, apologies, I missed that question. I think there was a point that perhaps came up. I think Elliot, you mentioned this around sharing information within teams, and I just wonder whether you might want to kind of elaborate on how teams might use CarMaker collaboratively. I know Will sort of emphasised that by having a virtual model, every member of the team can test the car and experience the car. And maybe there are some suggestions based on your experience as to how teams might kind of approach that, particularly in the early days of modelling.
Yeah, it's a good question. I'll let the guys jump in with more technical stuff, but I think philosophically, I would say between teams across universities, then there are elements that are shareable where you don't have any particular advantage. So if somebody's already got a fantastic track model, then just share that around. And I think University of Edinburgh shared some stuff, and all credit to them for doing so. So I think that's where you don't need to worry about competitive advantage of stuff that's just going to help your processes. So if somebody's managed to integrate a particular type of software into CarMaker and other people are having issues, then I would do that as well. But in terms of model sharing, I think I would simply offer the guidance of some kind of GitHub repository, SVN, something that allows people to see what's the latest version of something or what's appropriate for this type of test versus another type of test. So stick in some metadata, and metadata is critical, by the way. Make sure you're advertising what it is you expect your model to be used for. So if you know it's no good for ABS because you're using a particular type of tire model that's not going to help you in industry, we would say to people, well, make sure people know that, and they're not going to fall over by testing the wrong model for their application. I don't know whether Will and Mariana have got more technical responses than mine.
No, I think that covered it quite well. As I said, we'll share a basic car model to start with, and we're planning on working with teams. I guess we'll be a central point of contact for teams to make sure that car model becomes as representative as possible of every team's. But the teams we've met and spoken to have all been really friendly and happy to share data between themselves. So I'd just say I wouldn't be shy about going to another team and asking them for something. The worst they can say is no. The best is you get a really nice collaboration between everyone. Yeah.
The worst possible response is no. So yeah, absolutely. Don't be afraid to ask. It would be the way forward for sure. And I think it's just going back to the kind of model sharing stuff. You won't need a ridiculously high fidelity vehicle model if you're looking to test the response of a control system. So if you're just looking at whether the signals the control system receives and the signals that it outputs are what you want them to be, then just use one of the basic models out of CarMaker. Don't try and complicate it for yourselves. And again, as Will said, those models are available within the examples of Formula Student CarMaker.
Great. I then wanted to sort of touch on, we mentioned FSAI, and I think this might be something you're going to cover in your presentation, later on this afternoon. But just maybe for the benefit of those who are sort of on the line at the moment, where do you see the real opportunities for CarMaker in supporting teams as they develop their FSAI package?
Will, do you want to kick off?
Yeah, for me, the possibilities is just endless with FSAI. FSAI is all about algorithms, sensors, and CarMaker can do all of that virtually. As Elliot said, if you're testing a system, you can do all of it virtually, and you don't need a particularly high fidelity vehicle model. So one of the problems you might find when you're developing these algorithms is they work perfectly on their own, but then you put them into a real world scenario and something goes wrong you hadn't foreseen. With virtual test driving, you can really find those problems early on in a virtual world. So when you get to the test track and you get that limited time you have with the vehicle, your systems are far more mature than they would otherwise have been. You've already run them in the virtual world, and you know what the dependencies are. You're going to find problems that you hadn't thought of. So when I'm not that familiar with FSAI, but from what I understood from the talk earlier, the teams have very limited access to the car for test driving. So to have your model at the most mature possible stage by the time you get to that test is really imperative to having an efficient test.
To support that, I think the data that's provided in terms of what the models are, what the sensors are rather, what their parameters are, where they go on the car, all of that can be built into a CarMaker car. In fact, that's one of the things we're doing right now. And so your sensors stop being the problem, and your control algorithm is something you can focus on. And you can run those tests as many times as you want in the virtual world. So within the CarMaker software, you've got industry level ideal sensors, then we've got some high fidelity sensors, then and RSI sensors in another package available. But I would be taking the ideal sensors, I would be parameterizing them, or just checking their parameterizing in the way that the FSAI rules work. And as Will said, you just run loads and loads of scenarios. You could build as many tracks as you like. You can use the FSAI competition events and run that, and really test your system capability to death over and over. So yeah, I really think that CarMaker's capability for FSAI could be something quite exciting for the teams this year.
Because I think I touched on earlier as well, and Elliot just touched on there. Speaking to OEMs, the mileage required to validate autonomous driving features is insane. It's millions and millions of miles to make sure you have a robust model. And it's completely unfeasible in the real world, but in the virtual world, that's entirely possible.
Great, excellent. So we're lacking more questions, which is putting me on the spot a little bit. But I've certainly got one more, which is in relation, moving away from perhaps concept class, where the focus might initially be, to FS class. I'd be interested for views on from the panel on the translation of what you've simulated onto the real life car and the track, and I guess vice versa as well. So yeah, I would imagine that puts perhaps a premium on setup skills, so that you make sure that your car is set up as per the in real life, as per the simulation, and then also perhaps as you do tweaks and integrate what you've learned from track testing back into the model. That's another another sort of emphasis placed on those skills, and perhaps what teams might do practically, bearing in mind their budgets and their resource constraints, to get the best out of that process.
If you mean kind of in terms of building correlation confidence, I think where certainly my background in OEMs comes in handy is the progression we talked about earlier on. Kind of build up your knowledge, build up your data, build up your models. So if you want to do a correlation test to start off with, then make it as passive as you possibly can. So if it's an ICE engine, get it into neutral, or just coast it. and make sure you get the response you're after. So the powertrain's out of the mix, then add the powertrain in later. And the same kind of approach as much as possible. Do everything one step at a time, add one feature in. Don't go for a high slip dynamic assessment straight off the bat and see whether you can get your virtual model to drift in the same way as your physical car. That's going to be a stretch. So yeah, build those level of confidence in your correlation capability slowly and carefully, and I think pay particular attention to your tyre data that you're using, because there are lots of different sorts of tyre model, and they all come with different constraints and different capabilities. And use the online forum, use the reference data, and don't be afraid to ask questions.
Yeah, I think if it was me, I would concentrate on potentially early on in your season, validate your previous year's car, and it gives you a starting point. Once you've got a validated model, you can adjust little bits on it to see what it's sensitive to. It's something that's often done in industry, for example, is they might validate one model of a vehicle, and using that validated model, they can adjust it to have the different powertrains across their range, for example. Or we certainly have a customer that has validated that CarMaker will do the drive cycle that a human would do. And based on that, he's now changed the gearbox and transmission architectures and see how it performs with those new architectures in the virtual world, and make decisions based on that.
I think the other thing I might add to that, Elliot, is that for teams who are looking to go out and attempt to correlate their software, it needs to be planned, structured testing. So as Elliot mentioned, so starting simple and building up. But what I also mean from there is thinking about what are you looking to try and measure to validate and correlate, making sure you've got the instrumentation that's on your vehicle required to do that, and then think carefully about the accuracy of the instrumentation. So the simulation will consistently output, but any sensor you put onto the vehicle to measure any particular aspect will have an accuracy, a repeatability, and a resolution. And so know the limitations, and once you've got within the repeatability of your particular form of instrumentation, there's no point trying to improve it any further. Move on to the next item, and that touches on the importance of calibrating your sensors beforehand to make sure that you believe the readings that they're providing, and then doing a check calibration at the end of your testing, same as you would do with ABA in terms of the actual test you're completing. Make sure that the data that you're basing your decisions on is valid at the start and at the end of the testing.
Good. Chris, I'm conscious we haven't had anything from you. Anything you?
No, I've just been listening in. That's all. It's all very interesting. It's come a long way since our sort of inception back in, what was it, April, that we dreamt all this up. And it's sort of really good to see that we're taking sort of some of the tools we use in industry, and we push them onto the students, because I think that actually sort of the process is really important. I think up till now, maybe sometimes we sit in front of a computer and we design a car, but we don't really think about what is the process going into that, which I think is really, really important to take in, like your requirements at the start, and make sure we validate those along the way. I mean, typically we've validated those in terms of going out and testing the car or breaking a component on a test rig, whereas actually we've got some non-destructive methods which we can run over and over and over again, which is, it's not cheap because it's time still, but we're not actually committing materials to destruction or to have to be made, or etc. So I think it's a really, really good step, and I'd like to see more of it as well. So
yeah, it's a very valid point, Chris. And one of the differences between the teams who score very highly in design and other areas of the competition and those who score less well often is it's the engineering reason, rationale, and judgment behind the design decisions that you take or took, and being able to justify how you set your car concept using a spread of vehicle simulation before you then proceeded down a particular path, rather than, well, we just picked a 4-cylinder because everyone else does, which I'm not saying what people do, but that's kind of going from one extreme to the other. And so before you really put pen to paper, hand to mouse for the CAD screen, whatever it might be, is explore those options that are available to you. And some of you out there might be thinking, well, I'm forced to use a Honda CBR 600 because we've got 5 of them. Okay, that's what you're forced to use, but that doesn't stop you from simulating some of the options that are there. And then in your design report, you can say, due to financial constraints, our powertrain choice was fixed, but from simulation, we explored the other options and we understand that it gives us this benefit in this area, but this negative in this other area. If money was no object, this is what we would have chosen, but here's why our choice is good. So it's the best students, the best engineers, the best teams will always maximize what's available to them, both in terms of hardware and software, to sell the best car and the best story, if you like, in your static events.
I think to add on to that, I think it came up in a number of my sessions this morning with teams about, and we talked about the process we were using, and it's probably going all the way back to the start as well to make sure that that's all baked in. So you've obviously got some requirements, which is the rules. That forms part of your product design specification. And into that, you can then start to make some decisions on what your car's going to look like to best meet those requirements. Then you sort of roll into a bit of an FMEA, and actually when we start looking at things like CarMaker and your other tools, your FEA tools, if you're using anything for aerodynamics as well, is that you're looking at your FMEA to make sure you've designed things robustly, you've identified all your failure modes. And out of that, you sort of get your DVP, so your design verification process, and you're making sure that you're potentially exciting any of those potential failures or requirements. Like, for instance, you've got to get around the minimum turn radius. You can use IPG CarMaker or to simulate that minimum turn radius, and it's a tick in the box saying, yeah, we can go to the competition. Chris is going to be mean 1 year, he's going to set out a minimum radius turn, but we know we can meet it. And it's making sure that every step along the way is that you can verify your design in one way or another. You don't necessarily need to go out and test. You can do it digitally, you can do a hand calculation, you just make sure that all those bases are covered, because I think if they aren't, they're going to come back and haunt you, and they will trip you up, because that's just sod's law, which applies in engineering all the time. So it's making sure we don't have that, and we can cover all the bases, tick all the boxes, and you get to your end of your design submission, and you've got a DVP in there. And I haven't seen one from many teams, actually. What about you, Dan, at all? Whether you've seen any of those documents sort of appear?
Oh, no, I've never seen a DVP in either in a design report or on a design board explaining how you as part of your testing before the event, how you validated your design. And then optimized it for the specific events.
It's such a powerful tool as well. I think it's close.
Yeah, and I guess lots of people when they hear FMEA, if they've had the poor experience of it, they'll be shuddering and going, "Oh, not doing that." But it's a very powerful tool, and the trick is to not get too bogged down in the detail. It's for Formula student teams, you should be doing what I'd call FMEA light, if you like. So it's using the principles and the process to go track through. So what are my key objectives? And it is make a weekend racer that's cheap, make it something that's easily serviceable, make something that's quick around very specific events. And so then from that, you can use it as a structure and a framework to then go, okay, so what are the primary functions for each of those attributes? And what are the key failure modes? What could stop us from making something cheap? And the answer is piling too much tech on it versus performance, or it doesn't need to be right down to every nut and bolt like it is for automotive before you sign off a car that's made in hundreds of thousands. Premise it to what you're actually looking to achieve, and this is it's designing a weekend racer within the boundaries of the rules. But the framework of FMEA and then how that transitions into DVP and everything else is absolutely applicable to Formula student.
I think you guys have touched on a really interesting point there in the translations from this to industry. All too often I've seen teams in industry say, "Oh, I'm just going to go to XYZ test track and I'm going to drive a car around for 2 weeks and see what I find." Well, it's just not structured, it's not repeatable, it's inefficient, it's hugely expensive. Actually, the ability to write down what is the test I'm going to do, why am I going to do it, how long is it going to take, what is the output I expect from it, and then what's the following test sequence from that, and build that DVP is absolutely critical to an efficient approach to kind of real world engineering in an OEM. And I think that's where kind of historically hitting something with a hammer until it breaks and then moving into a simulation world is a really interesting approach. And it's still quite new for systems engineering as well. What is it you're trying to prove? What are the tests you require to do that? How many do you need to do? How long are they going to take? And build up your DVP from there. So, yeah, I hadn't really thought of it in those lines, chaps, but I think spot on. That's what I'd like to see teams doing. And we're here to help as well. Absolutely use the experience around you. But, yeah, absolutely critical. And the FMEA Lite feeding into that, again, super approach.
Excellent. So we've got about 8 or 9 minutes left. I was going to hand back to Dan for the last few minutes, maybe just to do a very quick recap and maybe just flash up the dates, key dates again, so people are aware of them. But from a practical perspective, bearing in mind that almost everyone's going to be working from home, certainly during this lockdown period. Hopefully in the new year things will kind of get a bit more back to normal. But in the interim, what kind of processing power, IT setup are people going to need to be able to run this software, and will that cause a constraint for them?
You don't need a particularly high performance computer at all to run CarMaker, especially for the simulations that we're talking about here. Here we run sort of high performance laptops, and it will run at 30 times real time. So even a moderate laptop will run CarMaker fine.
If you're interested in doing a test manager setup with 400 tests in it, then just leave it running overnight and come back in the morning and you'll be fine. So yeah, it's one of the beauties of CarMaker. It's not particularly resource intensive because the tests are typically quite quick with the way the fidelity of the models work. So yeah, it shouldn't be an IT constraint for people, I don't think.
Yeah, we'll publish minimum hardware recommendations once we've defined the specifics of the event. I think for the lap time simulation, it won't be a problem. It's just going to be a question of, based on the capability of your particular PC, just how long that iteration or number of iterations will take to run. If you're looking to practice the driver in the loop beforehand, then with that having to run in real time and having the graphical interface and all the inputs from the driver, it's more stringent hardware requirements for that. But we'll be able to test that beforehand with the tracks that we're providing in the template car, and so we'll be able to provide recommendations.
Excellent. Okay, well, thank you to everyone who's asked questions. Make a plug for the CarMaker stand in the expo if you want to visit it, ask more questions, and we've got some sessions with teams a little bit later on to answer their specific questions. But thank you to the panel, and I'll hand you back to Dan.
Thanks very much, Elliot. So I think it's a very good suggestion to just have a reminder on the dates. I'll see if I can operate PowerPoint this time rather than my ineptitude last time. So there we go, already on the correct slide. So as we're in the early stages of firming up both the event format and the software tools. So we've had a head start really with on the event format with the what we ran last year, this summer in the Virtual Dynamics, and we're in the process of porting that across and building upon everything we've spoken to you about today within the CarMaker software. So, but we're committed to trying to achieve the dates below, which is for by the end of this year to publish the event-specific key dates, and that will firm up specific dates for the headline items below. So January 21, at or around the time of the teams being confirmed for the 2021 competition, we'll publish the event-specific rules and the event-specific elements of the software. So teams are welcome to register for and download CarMaker well in advance of that and start to become familiar with the software and the interfaces and have a play. But the vehicle templates and the specific tracks that we're providing will put into a bundle and make that available all at the same time as the rules are published. And then for the 3 different events, so the lap time simulation and the design trade-off study, submissions for both of those are expected to be due late May, early June, likely to be early June, depends on the exact timing for all other aspects of the event. And then the driver in the loop event, we're trying to make that a live competitive element on site at the competition. But if within the restrictions of COVID and social distancing, whatever else, we can't host a live event, then we'll either move that to a pre-recorded video, or if it's possible, look at a way that we could do remote access to a single machine. But that's, I know I'm kind of freestyling on that one a little bit, but in theory, it's possible. It's just the reality of executing that. So the strong desire is to have that as a live competitive element for the concept class, but there'll be backup options if we're not able to deliver that this year. But certainly in future years, that's always our intent for that aspect of the competition. So thank you very much, everybody, for your contribution to the discussion. Thanks everyone out there for your questions. I'll let the IPG guys go now because I didn't give them a whole 3 minutes before their next session that they're presenting in. But yeah, thanks very much, and look forward to speaking to you soon to progress on this event.
Thanks very much, everybody.
So now for everyone else, we've got, thank you. There's the pre-booked sessions. So there's the IPG presentation starting at 2 o'clock, which I'd encourage some of your team members to attend. Then we have the pre-booked question and answer sessions starting at 2:15. If you have any other questions that have arisen from today and you don't have a pre-booked question, then you can start submitting questions either to the IMechE via the usual fs@iMechE email address, and they'll get forwarded on to the relevant parties, or use the Formula Student Question database. And again, we'll look to get back to you on questions submitted via there as soon as possible. So thank you very much, everyone. We'll bring the session to a close now. Thank you. Goodbye.